Hey, good afternoon, everyone. Afternoon.
Afternoon.
How are you? How are you, Kadir? How are you, Claudia? All right. I see four people here in the collaborate, and let's just check how many are there in the. I have four people here too. Okay. Hopefully, we have 2 hour class today, so hopefully, but everyone understands that the cutoff line, the cutoff point for uh, full attendance is 20 minutes past the hour. I mean, after that, it's going to be late, right? So hopefully within the next 20 minutes, the rest of the class will join us. Um, so uh, in our last class, basically what we, okay, so here's basically, what we did in our last class. We were just about to discuss uh, the second type of second example in present value of annuities, right? Remember, so uh, the first example, right? The lottery example was discussed last time, and I said, of course, lottery is very unlikely. I mean, unrealistic example. I mean, um, pedagogically, it it's not bad. I mean, it gives pretty much it explains well the idea behind the present value of annuities. But in reality, right, it's not very practical because it's not something that happens every day. But something that's more practical or down to earth is the case where you borrow money, right? And as I said before, if you borrow money, right? Suppose you borrow $1 million, and if you borrowed $1 million um, and at 10% interest rate for 30 years, and if that there's we know what's going to be the future value, right? I mean, if you use, let's say, the simple idea of future value of $1 million, right? 30 years later, right? If so you might think, oh, so it's 1 million times 1 plus R, which is 10%, right? Zero point 0.1 raised to 30. Oh, that's probably what I owe. No, this is completely wrong, right? This is completely wrong. Why? Um, simply because no lender waits for 30 years, right? No lender waits 30 years for you to come up with this future value, right? Um, in most cases, if you borrowed $1 million, then for whatever amount of money, not 1 million, but just even 10,000, um, the payment starts already next month, right? In other words, you're gonna make um, 300 of 360 of these, right, over the next 30 years. In other words, all the payments are in monthly installments, right? Uh, so the reality is it's going to be the present value of annuities. In other words, um, uh, there will be there will be 360 of these payments starting from 1, right? And what you're paying, because you're paying in the future, starting from the end of this month, excuse me, the payments already include your principal and interest, right? Of course, n is 360, right? This is n, and that should be equal. And this is the present value of annuities, right? I mean, if you do this, this is the present value of annuities, and which should be equal to your principal of 1 million, right? So it's a present value of annuity case. So again, in reality, right, when you borrow money, this is not the model, right? This thing is not the model, right? Oops. This is actually the case where if this is the case of investing. I mean, suppose you put $1 million into some stock, and just leave it there for 30 years. And on average, if the stock grows at 10% return, right? If this stock grows on average, in other words, every year the return will fluctuate. I mean, every year it cannot be the same number. But if you take the average, right? On average, it's going to be about 10%. And if that's the case, this is the model that can apply to that. But then if it is borrowing, the case of borrowing, it is present value of annuity, right? So the second example is exactly that. What is the second example about? It's about buying a car. Let's say you're buying a car and it's $30,000. And when you buy a car, even if you have $30,000, you don't want to spend your cash right away, $30,000 right away, right? So even if you have more, enough money, you don't just pay lump sum. Why? Because of the opportunity cost, right? Okay. Everyone understands what's opportunity cost, because if you have taken any microeconomics, you would know what opportunity cost is. Suppose you just paid $30,000 in lump sum cash to buy this car. Then, after buying this car, you discovered an investment opportunity that can give you an investment opportunity, stock, let's say stock X, a company X, right? That can give you 20% return per year. On average, it can give you 20% return. Now think about it. Then in your mind, because you used already 30K to pay for the car, you don't have 30K anymore, then you will be missing out on this opportunity to make 20% a year, right? On average, right? for the next 5 years. So, you know, you regret, but it's too late. You have spent that money. So then think about it. If you didn't use 30K to pay for the car instead, but how would you buy the car? Borrow money. If you borrow, right? If you borrow 30K at 5% interest rate, 5%, right? Then think about it. You use your own 30K to buy the stock, right? You use your own 30K to buy the stock and it gives you 20% return a year. But borrow 30K at 5%. Then simply from this, every year from the stock's return, the interest is already paid from the stock's return, and you will still have 15% left, right? In other words, this investment in stock more than pays for the borrowing, right? So that's the opportunity cost. In other words, you will be if you use that 30K to pay for the car in lump sum, right? You will be losing this opportunity. You will be foregoing this opportunity, right? You want to minimize that opportunity cost, right? So instead, you would borrow, right? So that's the idea. That's why you're financing. Even you may be a billionaire, and to a billionaire, $30,000 may be a peanut. But even a billionaire would not just spend, $30,000 in lump sum cash when there is an opportunity to make, a higher return than the interest on the borrowed money, right? So you have to weigh this. These are two, you have to weigh these two options. So that's why you finance, right? That's why you borrow the money. So basically, what this example is saying is you're buying a $30,000 car, but instead of paying lump sum cash, you make a down payment, 20% down payment. You have to make a down payment because without the down payment, you have no stake in it. Even 5% down payment. But in this example, you make 20% down payment, right? So 20% of 30K is 6K, right? 20% of 30K is 6K. So then what does that mean? The balance, 24K, is the principal borrowed. Isn't that right? Does that make sense? Everyone follows? Everyone is following? Let's see how many people are here now.
Yes.
I have 10 people. All right, some people are following, and I see 9 people here. So who's that one person missing? All right, so at least one person is following. I don't know what happened to the rest of the class, but so where is my, okay, here's the, so then now let's think about it. So the principal borrowed, principal borrowed, I would normally use just P, but if I use P in this case, it may be confused. It may be confused with the price of the car. Never mind, but we understand. principal borrowed is 20K, right? Of course, APR is 6%. Time, 5 years, which means, compounding frequency is monthly, because we are making monthly payments, right? We're making monthly payments. Then, of course, because of M, this will make, we all know, 6% divided by 12, 0.5%. One quick way to think about it is, if the interest rate APR is 12%, think about it. If APR is 12%, then monthly rate will be 1%. Isn't that right? But APR is 6%, which is half of 12%, right? Then monthly rate should be half of 1%, right? Now, 5 years, so total number of months or total number of compounding is, of course, 60, right? So given this condition, given this initial condition, right, our next question will be also then, what is the monthly payment? What is the monthly payment, right? What's the correct monthly payment? Okay. Or you can, if we know this already, let's say it is 500. But again, we don't know. The dealership, in the problem, it says the dealership said $500 is your monthly payment. Then the question is, remember, if that is the correct payment, $500 is the correct payment, the present value of all those payments must be exactly equal to the principal, right? It must be equal to the principal, right? In our example, the principal is 24,000, right? In our example. So another way to ask that question is, there are two ways we can think about this. If this payment, monthly payment, is the correct one, if this is the correct one, if this monthly payment is the correct payment, present value of all those $500 must be equal to 24K. It must be exactly equal to 24K. Okay? If not, that's not the correct payment, right? So let's go back to the problem again. The problem is, so the dealership says that your monthly payment is 500. The question is this a good deal or bad deal? Right? In other words, is this a correct payment or not? Okay? So then, as I said, there are two ways you can approach this. One, if this is the correct payment, if $500 is a correct payment, monthly payment, present value of all those must be equal to 24K. If it is not, then something's not right. The second approach is, because we already know what should be the present value of all those annuities, what should be the present value of all those annuities, which is, this 24K should be the present value of all those annuities. And that being known, right, this being known, then the question is, we need to solve. If we solve that equation for payment, right? The question is, what is the payment? Solving that equation. So in other words, we need to solve that equation, present value of annuity equation for payment, right? And what is, present value of annuity formula? We all know present value of annuity. I'll put it more like here. So present value of annuity is payment over R minus payment over R times 1 plus R raised to N. Okay? So if $500 is correct, if this is 500, then we should get 24K here. If we get anything more than 24K, then we've been overcharged, right? Or if we get anything less than 24K, which that can hardly happen, right? No lender will receive, lender will collect less than what the principal they loaned out. But anyway, so this is not likely to happen, but this can happen. This can happen. And if this happens, you've been ripped off, right? And if you've been ripped off, of course, you gotta call your lawyer, right? Something's wrong, right? You've been ripped off, right? So two ways to approach it. One, then we find the present value of annuities with the given payment, or we solve this equation for payment because we know present value of annuity must be 24K, or solve this equation for payment, right? All right, so let's go to Excel, and I believe you have all, all of you have this file opened in front of you. Do you have all this file in front of you?
Yes.
Okay.
Yes.
Only one person, only one participation. Who else?
Yes.
Alicia.
Yep.
Okay. Kelly. Okay. So that's like 3 people so far. Only 3 people. What about the Maria? You have this file in front of you, right? What about you, Braylon? Braylon, do you have this file in front of you? Excel file? How about you, Claudia? Claudia, you have this file in front of you?
I've already answered you, Professor.
Oh, okay. I'm sorry. I didn't.
No, it's okay. No, but I have it.
Yes, I have it, Professor. I can say it.
Okay, good. Mukhtar, do you have this file in front of you, Mukhtar? Nikri says yes. Kadir, do you have this file in front of you? Kadir? Ranisha, do you have this? Kadir?
Yes. Yes.
Okay, Ranisha, you have this file in front of you, Ranisha? Sapphire, are you there? All righty, so I guess a couple of people have fallen out. So remember, we did this example last time. This was, what? The lottery example, right? But the lottery is, so just like the lottery example, all we need to do is just drag it up, and then we'll have the present value of all these payments. And then this is, obviously, this is not right. Why? If this is the correct payment, then present value of all of them should be equal to 24K, but it is not. It's greater than 24K. So what is this? This is the proof that you have been overcharged, right? You've been overcharged. Another way to find out is by solving for payment. And then to solve for payment, then we need to solve this equation for payment, right? We'll have to solve this equation for payment. Now, to solve this equation for payment, now the payment is the unknown, right? And you see that this formula can actually be simplified further, right? But there's a reason. There's a good reason why I put it this way. But think about it. If you see what is the common factor, right? Common factor is payment over R. So if you factor out the common factor, it will be simplified. So this one will be 1, right? This term, payment over R, will be 1 because you factored it out. The right term in the right will be 1 over 1 plus R to the n, right? But now think about it. This is in the textbook, and there are several variants of this formula. It's the same, basically it's the same formula. And in the textbook, they gave you a formula like this. The formula they gave you in the textbook is something like this. And then you have, times. This is what the textbook gave. But that's very ugly. Why? Because it's like this. It looks quite complicated. It looks so complicated, right? So actually, you can tell that what you see in the textbook is just another way of, if you multiply this to this term and divide it by R, right? That's what but I don't like that. I don't like that variant. I don't like that version because that is so cumbersome to use. So I keep using, this version, right? And there's also a good reason for that. It has a benefit. I mean, if you use this version, it's got a benefit of separating, being able to see the effect of interest rate and the effect of N in separation, right? So I'm gonna talk about it. But what I want to use is not this version, right? It's not this. But think about it. If instead of factoring out, although payment over R is a common factor, I will simply factor out payment only, payment, right? If I factor out only payment, then this one will be payment over, and this one will be 1 over R because I factored out only payment, minus here, this is going to be 1 over R times 1 plus R to the n. Okay? Then think about it. And don't forget that the left-hand side, we're not repeating it. We don't have to repeat it. But the left-hand side of this equation is PVA, right? So a lot of students who are not strong in math, they just forget, or they probably, they don't, just they can't keep track of the train of thought. The train of thought, you shouldn't lose the train of thought. The train of thought is, beginning with PVA, right? So the left, that once you say PVA is equal to this, and which is equal to this, which is equal to this, PVA is, always there. You have to remember that. Left-hand side is PVA, although I don't need to repeat it because equal sign is already telling me which is equal to this, equal to that, or, which is equal to this. Okay? So then when you are down here, we can combine this. Why? Because, by using the common denominator, and what's the common denominator between the two? You might say, oh, common denominator is R. No. It's the common factor, not common denominator. Because if you use R, if R is the common denominator, you cannot reduce this to R. You cannot do that. So it's actually a common multiplier. But the common multiplier is the common denominator in this case. So we can consolidate or unify the denominator, and the common denominator is R times 1 plus R to the n, right? Think about it. If we have 2 over 1, 1 over 2, minus 1 over 3, right? Or 1 over 6, let's say, minus 1 over 6. How would you do that? You'll have to find you'll have to unify these two terms by common denominator. And the common denominator is 6. It cannot be 2 because 6 cannot be reduced to 2. It is possible, but if you reduce it to 2, then 1 will be 1/3. It's not gonna make it easier. So, but if you unify it by 6, then all you need to do is, you'll multiply this by 3. You do the same thing to the numerator, right? Whatever you do to the denominator, you do the same to the numerator. So then the left term will because the denominator became this, R times 1 plus R raised to n, you have to do the same to the numerator here, right? But there's nothing to do to the right term because nothing has changed to the right one. Okay? Now, we are at this point, and then think about it. I've been telling you over and over that any equation, no matter what, all equations can be solved if we identify z equals x times y format, right? And here, the left-hand side is PVA, isn't it right? And then think about it. This is already presented in z equals x times y format, isn't it right? It's already in z equals x times y form, isn't it right? This is z, this is x, this whole thing is y. Okay? And think about it. This z is x is our unknown, right? And solving for x is z divided by y, right? Solving for x, right? And just the same, solving for payment is PVA divided by the thing in the bracket. But everyone understands that when you divide by something, dividing by something is the same thing as multiplying by the reciprocal, right? Dividing by something is the same thing as multiplying by the reciprocal. So if we can multiply by the reciprocal of the thing in the bracket. And what's the thing in the bracket? The thing in the bracket is we know what's the thing in the bracket. So the reciprocal of the thing in the bracket is then and the reciprocal of the thing in the bracket is r times 1 plus r raised to n over 1 plus r to the n minus 1. Okay, this is the reciprocal of the thing in the bracket. So that way, we can find payment, right? So let's go back to the Excel file then. Let's go back. That formula, I put it here, put it there as well. So basically, we can find now what the exact payment is. So because present value of annuity has to be 24,000, because if the payment is correct, the present value of annuity must be equal to the principal. And then as usual, we need R and N, which is the same thing always. If it is, as long as it's 6% and monthly, right? So the payment using that formula, right? All you need to do is PVA times R times 1 plus R raised to N divided by, open parenthesis, open another one, 1 plus R raised to N minus 1, close parenthesis. Okay? Is everyone, so if you hit enter, voila, 463.99. That's the correct payment, right? That's the correct payment. And then, from this, this is the second proof. First proof, right, that this is a bad deal. The PVA was when, if the payment was 500, PVA is greater than our original principal. So this is the proof that something's fishy here, and this is the second proof that this is the payment, the correct payment. So if it is $500, that's what the dealership said, and every month you were being overcharged by about $40, right? Everyone got the same result? Everyone got the same result? Everyone is quite, awfully quiet. Did you get the same result, everyone? Was it Claudia that's said? So you got the same result, everyone? Alicia, did you get the same result? Claudia, did you get the same result?
I'm trying.
Okay. All right, Sapphire. Okay. So I'm leaving it there, and But don't try to copy like G23, E23. That's only the cell number. That's only the cell location. What you need to because think about it. If I move this somewhere else, if I move this model to somewhere else, then it won't be the same thing. It won't be G23 or it won't. If I move this model around, you should be able to enter the formula just by looking at this. Oops. Okay, by looking at this. And another thing is, some people might wonder, what happened to the outer bracket? What happened to the outer bracket? Some people might wonder. Why don't I, why don't you use, Professor, why don't you use the outer bracket? You may or may not. It's not totally necessary. Why? Because when you multiply something to a fraction, it gets multiplied only to the numerator anyway. And the numerator, so the numerator is basically a multiplicative function or product. So, I mean, there's nothing, if there's any additive, terms, you would need a bracket around it, additive, right? But if it is, there's nothing additive, you don't need, right? But this outer bracket is used only for the, only in the denominator, because in the denominator you need, because there's an additive term, right? There's, 1 plus r raised to n, and then there's minus 1. So there's an additive term. So you'll have to use, outer bracket. The bracket is basically parenthesis. In Excel, in Excel, you don't use bracket, right? You don't use bracket. It's just, always, just parenthesis. All righty. So if you got the same result, now let's think about what amortization is. Let's think about amortization. So the next this type of question would not be only limited to car financing, but most of all, home financing, right? House, if you buy a house, basically, what do? You have to borrow money, right? Which is called mortgage loan. And then think about it. When you are dealing with mortgage loan, you borrowed $1 million to buy a house, right? Let's say the house is, $1.5 million. And, $500,000, that's your down payment. Usually down payment would be smaller than that. But then, you borrow 1 million. So you'll have to pay back 1 million over 30 years. I mean, there can be 10-year, 15-year, 20-year mortgage, 30-year, but the maximum is 30-year mortgage. And if you're paying it back over 30 years, it's called amortized. Your debt is amortized. And what does that mean? You're not just paying back, but you're paying back through paying down. You're paying back your principal through paying down. Okay? What is paying down? Paying down means, the principal balance is going down. As you make the payment, the principal balance will have to go down. Isn't that right? Because as you make the payment, right, the principal decreases. Principal balance goes down. Hence, pay down. But the word amortization has a very interesting meaning, because the word comes from Latin. Okay. Because obviously the word didn't just fall out of sky. It comes from somewhere, and the word amortization has the radical of the word, or the root, Latin root, Greek root, whatever. It's Latin root, but it's not difficult to find. It's this. That word means death, right? In French, that's dead. Il est mort. Il est mort. He's dead. Il est mort. Right? In English, word, immortal, mortal, immortal, mortal combat. Right? In French, mortel, immortel, mortel. And also, mortuary. What's a mortuary? It's a mortuary is a funeral home, actually. Mortician, funeral director, right? Mortician. Well, so why is it so ominous? I mean, why does that have such an ominous, meaning? I mean, morphologically, in linguistics, there's, an area called morphology. You know what morphology is? The shape, right? Why is the morphology of the word so ominous? Because what it means is you bring the death to your debt, or you bring your debt to its own demise. Well, think about it. As you pay down your loan, right, the principal balance goes down, so eventually the loan will be brought to its death. Hence, it's called amortization. But then the amortization, the pattern of amortization, right? First of all, okay, here. Maybe I'll okay. So let me draw a graph. The graph will of course, this is the principal balance, right? This vertical axis, that's the principal balance. And this is timeline, horizontal axis, of course, timeline. And the principal balance at the beginning, it was 24K. Isn't that right? At time zero, it was 24K. Time 1, time 2, time 3. And then, finally, this is time 60, right? Month 60, right? And then month 60. So the principal balance will decline like this. And at month 60, at the end of 60th month, it will have to be zero, because you will have to completely pay it off. Now, so you see this curve, which is basically the plot that's connected by a line, shows a declining pattern. But this pattern is called decay. This pattern is called decaying pattern, decay. Now think about it. Slowly what you see here is the slope of this curve is getting steeper as time goes on. Early on, the slope was flat relatively, right? But as time goes on, as time goes by, the slope gets steeper. And this shows, this is the pattern of, this is, decaying pattern. What that means is, over time, the decay accelerates. Think about it. If something decays over, eventually, end of decay is what? Death. Isn't it right? End of decay is death. So the principal decays, declines in this pattern, right? On the other hand, so here, this graph shows something like mortgage loan over 30 years. But to fully explain this, I think we will have to take a break first. So it's 2:53. So let's take a 10-minute break, and when we come back, we'll come back, at around 1:03 or 1:05. So let's take a 10-minute break, okay, and reconvene at 1:05. Okay, 10-minute break. All right, we're back. We're back. So uh, uh, so um, let me open this file in web browser. I believe I can do that. And in the web browser, there's a way I can draw on it. So let me open the same file. Okay, so here I'll open it. Okay, how do I open this? Oh, maybe not this, but I can do from here, right? Compounding, open with, open with, open with Microsoft Edge. Okay, so all righty. Now, this looks like 30-year mortgage, right? Maybe how much time do we have? I guess I just wanted to mention this. All right, maybe this is not necessary. Let's just go to. So this looks like a 30-year mortgage, how it is amortized, and it looks like the monthly payment is about $700. And so if you multiply that by 360, the total payment over 30 years is this. Started from 2010 March, and then March of 2040 is the payoff date. And of course, this curve, I mean, right? That's basically principal, how principal goes down. But what is the principal? It looks like the principal is about $100,000. It looks like the principal is about 100K original. How do I know? Because after making the first payment, the balance dropped to 99,315. So after the first monthly payment, and monthly payment is about 700. Interesting thing is, you might wonder, and the bar, these bars, the height mean these bars, that's 700, right? The bars represent the monthly payment. That's why it's all even through and through. But then you might wonder, if the left end of the curve, the principal, is 100K, and how can it be the same thing? The height, how can the height be the same thing? I mean, this is only 700, right? How can they be on the same level? Well, you have to understand that they are using two vertical axes here. They are using two vertical axes. One vertical, in the left-hand side, one vertical axis in the left-hand side that represents the principal balance. And the other one, the right vertical axis, that represents the payment. And then, so they don't go by the same scale, right? You understand? They don't go by the same scale. In the right vertical axis, let's say each increment is like $100, right? 100, 200, 300, 400, 500, 600, and 700, right? Each increment is $100. But in the left vertical axis, each increment is like $10,000, 10K, right? I don't know if I drew it correctly, but if it is 10K, right? 20K, 30K, 40K, 50K, and so on, right? So the top of this 100K, right? So they are on two different scales, right? So then, it should make sense. And then in the vertical bar, right? The yellow portion is the principal paid. Yellow portion is the principal paid. The green portion is the interest paid. Interest paid. So then you can tell, you can tell that the interest is it's flipped actually. I'm sorry. What I was trying to say is why is it? Okay. This is the interest paid. This is the principal paid. Okay, so early on, it's mostly interest. Out of this $700 monthly payment, early on, it's mostly interest, and interest declines in a decaying pattern, right? And principal, as interest declines, principal paid, that portion of the monthly payment, right? Principal portion of the monthly payment increases exponentially. Okay? So in other words, principal goes down after each payment, right? Principal balance goes down. And as the principal balance goes down, interest will have to go down because interest is some percentage of the principal balance, right? Each time. Okay? So, so I just wanted to also say that when we have the growth, right? I mean, if you represent growth on a graph, and this is time, of course, there can be three patterns. One pattern, this is pattern one. It's constant growth, right? It's constant growth. This, that's decay, right? Growth is decaying. On the other hand, something like this. It's called exponential growth or exploding pattern, right? So if we have, if I label this A, B, and C, right? A is showing exponential growth pattern or exploding. Why? You know why C is decaying, right? Early on, it was growing at a very steep, growing at a fast accelerating rate. But as time goes on, the slope gets flatter. What does that mean? The growth is slowing down. Well, it's, the growth rate is decaying. Exponential, early on, it was relatively slow. The growth slope was flat. And as time goes on, the slope gets steeper and steeper. That's explosive growth, right? Because the growth rate is accelerating. As opposed to that, B, it's constant. There's no change in growth rate, right? So exponential growth is not something like this. You cannot say this as exponential growth. You cannot call this exponential growth. I mean, in reality, the growth pattern would show this is very smoothed out. The reality is something like this. But even if when you smooth it out, it will be the smoothed out pattern will be a straight line. And if we have something like this, the reality would look like this. But if you smooth it out, it would be like a decaying pattern. The reality of this would also be like this. But if you smooth it out, it will be an exploding pattern. And the word exponential is very powerful. And some people, like to some people like to use the word exponential growth because it's very powerful. And they say, oh, since I have assumed this role, since I have taken the responsibility of this organization, we have seen, exponential growth. And they just like to use that word. But if the graph is actually, if the data is showing actually this pattern, it's not exponential growth. If it is showing this pattern, it's not exponential growth either. But if they are saying that, that means they don't know what exponential growth is. They don't know what exponential growth is. They just like to use the word because it sounds very powerful, right? They don't know what they're talking about. Okay, so I just, so the point is, in amortization, right? In amortization, interest declines. I mean, if you flip it, right? Interest declines just like the way the principal declines. And then I call this decay, but actually the rate is increasing, so it's more like exponential. But the reason I called it decay is to associate it with death, right? Like in amortization. But the principal is the portion of the payment the principal takes is increasing at an exponential rate. Okay, now, so where was I? So let's go to our Excel file and let's go to amortization schedule. Now, so let's go to row 29, and amortization schedule is a schedule that shows the breakdown of this payment into interest and principal, because from monthly payments must break down into interest and principal. Every time it's going to be different. Principal will increase exponentially, interest paid will decrease exponentially, right? Payment is always constant. Principal balance will decrease also exponentially. So to do this, first, you must have this payment number already filled in. But the payment, you think, I manually input all those, payment numbers 1 through 60. No, there's no way I would do that because it's a tedious job. Instead, what I would do is I will first plant a few seeds, few seeds of the numbers, and then I will generate the number series. So I put 1, 2, 3, and Excel is so smart. Excel is smarter than you think. It understands your intention. When I planted 1, 2, 3, Excel knows that I want to generate a series of integers. With integers have intervals of 1. So Excel knows that. So if I highlight these 3 cells and drag it down, you see there's a small box appearing to the right of the column, and the numbers change, and that number is the row number. So that means if that number reaches 60, that means that's the 60th row. So we stop there. So the number is generated. Next, I will enter payment, and we know the payment is $463.99. That's every month, right? Monthly. So I want to drag it down. But if I drag it down just like that, you know, what happens is next it's going to be 824, and then 825, 826. So then it's going to be a hell. It's going to be a mess. So I would lock first, function key, right? And F4. Function key and F4, right? If you have just, IBM computer, right? I mean, PC, IBM laptop, IBM clone laptops. I mean, anything other than Apple, right? Anything other than Apple, you just hit F4 and it's going to work. But if you have Apple, you have to press both function key and F4. And it's going to lock.
For me, I have to press FN and then press
F4.
No, I'm saying like on my Windows computer, I have to press FN in order for my F keys.
Oh, is that the way it works? I mean, normally if you just hit F4, it's gonna work. Unless it is
because for
an
my
Apple computer.
F4, well, for my F4 laptop, it also has like a rewind button. So that's why I have to press the FN button in order for the
you just adjust it accordingly, right? To your computer setting. So in that case, then, function key, right? FN, function key and F4, right? Apple computers, function key and, F4. But, as far as I know, most other PCs, just F4 will work. And then hit enter. And then you can now drag it down. Okay? Bring the cursor to the southeast corner and bring it down. So every month, this is, the payment is constant. So when you do that, at the bottom, row 89, I have already entered sum command, right? So I'm summing up sum of all those payments. It will be there. Next, how much of this payment is interest? Well, interest is monthly is 0.5%, isn't that right? So, but interest is 0.5%, which is an E23. It's 0.5% monthly, so it's going to be every month. It's going to be like that every month. So you lock it again. You lock it, and then that's only interest rate. The dollar amount of interest. How much of this is interest? Some people say, so E23 times 463.99. No, this is the payment. Interest is some percentage of the principal, isn't it right? And at time zero, what is your principal? In the first month, at time zero, what principal are you looking at? What's the principal that you're facing at time zero? Anyone?
0? You said 0?
Would it still be 460?
0? Your principal is 0?
No, I'm asking you, are you saying 0?
No, how can
Oh my
use
God.
your good
I'm having a
sense?
bad connection. I cannot hear what you were saying. Did you say the number was 0?
No, it
Okay.
cannot be. What what I'm saying is at time zero, at the beginning of the first month, right? You haven't paid anything, so you have the full principal. You have the full principal in front of you. So what's that principal at time zero?
The same amount.
Would it be 460?
Would be what?
460.
No, no, no. I already said no, it's not. I already said some people say 463.9. No, that's the payment. That's not the principal. What's the principal at time zero? Okay, let me
50%? Or that's the interest?
50%? There's no look. It's 0.5%, not 50%.
Oh, 0.5. Okay. Yeah,
That's the
I saw
interest
it wrong.
rate, right? Where can you find 50% interest rate? I mean, if you borrow money, will you borrow money if the interest rate is 50%? That's even unrealistic.
No, I saw it wrong.
Because you seem to be having, difficulty hearing me, let me write it down here. What's the principal, right? What's the P at time zero? Okay?
So that's the beginning of the time.
Yeah, that's the beginning of the time. So what's the principal at time zero? In other words, what is the original loan amount at time zero? Principal is the original loan amount, isn't that right?
Yeah, because that's what you got in the beginning of the year.
Yes, so what is it in dollars? What is it?
I don't want to say the wrong thing.
It's better. It's still better than, not saying anything. What is this problem about? Right? Remember, what is this problem about? What are we amortizing? What are we amortizing?
We're trying to get the initial payment for the beginning of the year, year one.
No, no, no. This is not year one. This is month one, not year one. We have 60 months. Do you think
Or the
this is
beginning
60
of
years?
time.
Huh?
The beginning of T, the beginning.
Yeah, yeah, but at the beginning, what is the principle? You're losing perspective again. You're losing. What is this problem about? This problem is about maybe this problem is about this. This problem is about car financing, isn't that right? It seems like nobody's following anything. You're buying a car, right? The price of the car is $30,000, but you made a 20% down payment, which is $6,000. So the financed amount is $24K. And you try to find the correct monthly payment. So you found the correct monthly payment, which is what? $463.99. Then at time zero, what is the principal that you are looking at?
That's the 24.
Yeah, that's the 24,000. This is the principal at time zero, isn't that right? And who said that? Who was that? Who said 24,000?
Tia.
Tia. Okay. Okay, at least one person is following. Okay, Tia, so you'll get 0.5. So think about it. At time 0, that's the principal. So interest rate times principal. So that is the interest paid in the first month. Then what should be the principal paid? Hmm? What is the principal paid? Have you
Is that the
lost that
six?
again? No, no, don't
Was
give
that
me
the
the
six?
number. There's no point in giving me the number. Give me the logic. What matters is the logic. What's the principal paid? Like, think about it. Out of this
The
payment, right?
463
Hmm?
minus the 20.
Yeah. That minus
The
829
24K.
minus? Huh?
It will be the 463 minus the initial payment.
No, 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 not it's not initial payment. Interest paid. Interest paid.
Oh,
It's interest
okay.
paid. So give
Interest.
me. So how do you say that? I mean, I already put B29 minus. Then what should follow? It's the payment
C29?
minus interest paid. So that
The
is
interest payment.
B29 minus
C29.
B29 minus
C29.
C29.
Yes, yes, of course. Who said C29?
Claudia.
Say that again.
Claudia, can you hear me okay? I feel like my
Claudia.
microphone is low.
Yeah, you need to adjust your microphone because my audio volume is at 50. Oh, I'm sorry. I thought it was. Normally it
I'm
is
like
set at
yelling
50%.
I'm yelling at my laptop right now so you can hear me.
Okay. But there is a lot of static sometimes, and there's it's like it's choppy. It sounds choppy, right? The first part is chopped off, and the last part of your enunciation, it's not fully enunciated when it is heard over the computer. Um, it's almost like the first part of it's not fully enunciated. The first syllable is always chopped off. Only last syllable is heard. I don't know. I mean, it's probably it's the delay. I mean, maybe if we have 5G network or 6G network, it may be better. But I don't know. This is 4G network or 2G network. I don't know. Yeah, but this is and that's the principal paid. And then at the end of the first month, what is the principal balance now? What's the principal balance at the end of the first month? Hmm? Don't you think from the principal balance will go down from this by as much as this? Just think logically. It's just logic.
That would be what's left off.
Yeah, that's what is meant by balance. Balance is what's left off, isn't it right? After some transaction. That's principal balance, right? So the principal balance, originally it was this. It goes down by as much as this, right? And in the second month, we're gonna just copy this down, but something's wrong. In the second month, something is off, so we have to make some adjustment. Let's take a look at the interest rate. Interest rate E23, that's right, that's correct. But what is then G24? G24 is right below G23, but actually there's nothing in G24. You might find it weird that row number was jumps from 23 to 27. That means 24 through 26 was hidden. It was collapsed, and I did it deliberately because there were a couple of examples below row 23, but that has nothing to do with this problem. So I hid it. And there's nothing in G24, G25, and nothing below G23. So we cannot leave it like that. We need to make adjustment, right? We need to make adjustment. So basically, you know, it's 0.5%. And then the principal balance, think about it. At the beginning of month 2, principal balance at the beginning of the month 2 is the same thing as the principal balance at the end of month 1. Isn't that right? Principal balance at the end of month 1 is the same thing as the beginning balance, the principal balance at the beginning of month 2. So you just you just make that adjustment, right? So the principal paid in the second month is this. Logically, there's nothing wrong with this. And then here, principal balance goes down by as much as this, D30, but it goes not from G24, it goes down from, what do you think? From this, E29. It goes down by as much as D30 from E29. And there you go. Now everything is immaculate. From here, let's just walk through the park, right? Then you highlight these 3 cells, highlight those 3 cells, and bring the cursor to the southeast corner and just drag it down until you reach month 60. And then when you are at month 60, this is the proof that you got it right. Why? This column E is the column of what? Column E is the column of the principal balance. Isn't that right? So I'm gonna, just to make it easier to see, I'm gonna freeze pane here. So if I freeze pane here, then I will not lose sight of the, I will not lose the labels as I move up and down. And that's the column of the principal balance. So by the end of month 60, the principal balance must be 0 because it's paid off. Because it's paid off. So if you see, if you don't see 0 there, something's wrong. You didn't do it right. And then column D is the column of principal paid. So think about it. Sum of all of the principal paid must add up to 24K. Isn't it right? And column C is the column of interest paid. And then think about it. If you add principal paid to interest paid, it should equal to all the payments, sum of all the payments. And this is sum of all the payments, right? And it is exactly equal to sum of interest paid and sum of principal paid. Okay? So that way, we know our amortization schedule is correct and, you know, immaculate. And also, so amortization schedule is not only showing you how the monthly payments break down into interest and principal paid. And as I said earlier, early on, it's you pay the mostly you pay interest. You pay the most interest early on. Interest gets smaller and smaller and smaller as time goes by, right? Finally, it's on. And then early on, principal paid is the smallest, right, in the first month. But as time goes by, the principal paid increases, like, you know, exactly in the same pattern, right? In the same pattern, right, as this, right? So that's the amortization schedule. And it also shows you not only that, but let's say after 2 years, let's say after 2 years, you came by a large sum of money. and you're tired of making monthly payments, so you want to pay it off completely. You pay it off. So what is the payoff amount? This is the payoff amount because it's the remaining principal, right? But of course, in reality, it will be a little more than that because there's some fees, transaction cost, right? Some documentation fee and some. So, but those fees may not be more than like $20, at best, $20-$30. So pretty much, but this is the payoff amount. That's what the and that's what the amortization schedule is about. And think about it. This was just car financing example, right? This is just car financing, so it's just 60 months. But we can do this for even 30-year mortgage, and it doesn't take any more time. I mean, if you get the hang of it, you can build a schedule like this in like 2 minutes. And even 30-year, amortization schedule, you can do it in, just 2 minutes as well. Won't take any more, any more minute. All right. So everyone got the same result? Okay.
Yes.
Okay, great, great. Okay, good. If you got the same result, then all right, our time is up. So let's call it a day. That's it's not a great day, but still, enjoy the rest of the day, and I will see you guys on next Monday. Okay. All right. Have a
Thank
great
you.
afternoon.
Have a good weekend.
All right. All right, you too. Take
Thank
care
you.
now. All right, you're welcome. So I'll stop recording.